presentation, Display GUI Multimedia Options with the P2. Before I introduce Ray and we get started, just a little bit of quick housekeeping to go over. First things, I've come across a large number of these displays, 140 units. I'm going to get them in stock. Chip rewrote the driver yesterday in 2 minutes to make this work nicely. And I just want to know if you guys would buy them if I bring them in. Have 140 units, they'd sell for 40 bucks. Who's down with that?
That's me too.
Okay, I think that's a fair price, so I need some feedback. These devices are always surplus and they are always limited supply, and you can get them off Alibaba, but maybe never the same thing twice. P2 eval board Rev C is coming. The PCBs are running late from the supplier, some sort of issue. This is the email we got yesterday. Our pick and place line's ready to go, and we're stalled waiting for these things to come in. So all I know is we are trying to fix it. We'll keep you posted. Also, Team Oz, as usual, is doing productive things. This is a picture of Richard Morrison. You may have seen this yesterday with his long-range ESP8266, ESP32, Wi-Fi integrated sensor data collection with P2. And I know he does good work, so whatever he produces, I'm sure will be shared at some point. Also, coming up, so I'm keeping a list of all of the presentations and the YouTube links. You guys already know I'm kind of trying to train you into going here for information. I think it's starting to work, but you can see what's coming. We got Eric Smith's presentation with Flex GUI and FastSpin, and then we have an educational product from another informal member of Team Oz who lives in the UK, James Casca. It's called Visual Programming with Touch Logic Control. That's July 7th. And then Chip has his debugger system working, and he's going to share it in mid-July. And then we're waiting on MicroPython to get formally booked, and also the SmartPin documentation from John Titus. So this is what we've got for P2 chips. We have 2,700 in stock. We've not ordered any production ones yet. They have an 18-week lead time. It's a pretty big commitment. We have some hurdles to overcome to get there, specifically dollars and costs. So we're trying to raise the funds and get this going, pay off our final bills. But this is what we have, at least for the next 18 weeks. Next, courtesy of Johnny Mac. Thanks, John. You'll recognize this list. This is our keeper location of all objects that we need. And as they get produced, I invite all of you to produce them. I'm going to post a link to the chat. So I'm going to actually mute several of you who may be causing some issues with audio, and you can bring yourself back in whenever you want. I'll post a link to this so you can access it. If we receive drivers, we don't have a real formal plan, but as you know, OBEX is down, and we're going to use our GitHub, but we're going to have some kind of front end that Jeff is going to sort out. But we will be posting any drivers we get here. And I have a few ready to go that are audio that look really good. So that's it for me. I want to pass it back to Ray Allen, thanks for joining us. Your first experience with Parallax was with the Basic Stamp 2 15 years ago, and you've met many of us at Propeller Expos since then, and you've always had a lot of cool display stuff.
So, great, thanks Ken, appreciate it.
Click on share screen, away you go. Ray's gonna move kind of fast, and any of his content can be seen in the video. He's gonna answer questions towards the end if we can. And his slides, by the way, what he's sharing right now is posted under the Propeller 2 live forum link, first post.
All right, good morning, everybody. This is Ray Allen, Rayman in the forum. I know a lot of you are there, so it's good to see you guys. And today I'm going to talk about display, GUI, and multimedia options with the P2. And I've been a long time P1 user, but things are much, much better now with P2. And I really don't want to go back, to tell you the truth. But here we go. Let's get started. So here's, let's see if I can figure out how to,
there you go.
Now it works. Okay. Here's my kind of list of things I love about the P2 here. We got digital video output. We got DACs in every pin. We got lots of pins. Got a higher clock speed. We get more MIPS because instructions only take 2 clocks now. We got the FIFO, streamer, interrupts. We got the lookup table RAM, which is great for index color modes, but you can also put code in there. We got these new pixel mixing operations that I don't really understand yet, but look forward to getting into that. And we have the Cordic math operations, which are great for doing things like rotating images on the screen. And we also have USB on the pins with smart pins, so that's really convenient for doing a GUI. So the first thing I think about is the digital video output mode on the P2. This is really a wonderful thing. I think it was kind of a last minute addition, but it's great to have that. It uses groups of 8, needs 8 pins to use it. There's basically 4 channels of differential signaling, 3 for RGB and 1 for the clock information. And this uses TDMS, the same as like HDMI, DisplayPort, panel link, that kind of thing. And basically we're running at the minimum possible, even with the P2 at 250 megahertz, we're running at the minimum possible, well, the minimum allowed by the rules, the minimum allowable display rate, which is a 25 megapixel clock. So it puts out pixels as 10-bit data. It turns out 8 bits into 10 bits using a coding system. And it's always 24-bit color. And so we're kind of limited to VGA kind of resolution at this usual 60 hertz refresh rate. But Chip, I think it was Chip that figured out you can actually do 720p at 24 hertz. On some televisions will take that, because that's, I guess, the movie speed, and I guess some Blu-ray players can output at this 24 hertz mode. So the TVs are rigged to accept that. And I recently figured out you can do 1080p at 11 hertz. I was kind of amazed that works, but some DLP, at least my DLP projector will actually take that. So here's a kind of example of the kind of images you can get. So this is kind of pretty good quality, I'd say. It's 16-bit per pixel using HyperRAM. This is way too much to fit into the P1 memory hub RAM, but using a HyperRAM or HyperFlash chip that I'll talk about later, you can do it. And this 1080p image did with my projector, that is absolutely amazing. Good quality. And I was kind of surprised it actually works at 11 hertz. It must mean the TVs and these projectors must have some kind of internal buffer, because there's like no flickering at all. But with the regular monitor, you can see you get a widescreen VGA, 56 hertz. I think that's good. That's fast enough. I think most monitors will take that. And one nice thing about 16-bit per pixel is it's smooth, and a lot of these TVs and monitors can actually upscale that, so it looks even better than you might think. So one thing about its digital interfaces is it's actually the same signals on several different types of connectors. There's HDMI, DisplayPort, all these various things all has the same kind of signal, and you can switch between them with passive adapters. The DVI is kind of interesting. I'm really a fan of HDMI now, but DVI is actually, I think, has some advantages. And one is that you can actually output analog with it. And it also has option for dual link. When dual link uses an extra 8 pins for a second link. And it might be possible to actually use dual link to get more data to the monitor, increase your resolution. I'm not really sure. That might or may not work. I don't know, but it's kind of interesting. Some of the big monitors need that dual link. And the one thing you don't want to use is this analog one, because that's analog only. Okay. So the regular digital video uses just a subset of those 10-bit codes. HDMI means it's actually a lot of different things. It's the connector, it's the logo, but it's also the way they stuff analog audio into the stream. And they use these extra codes to do that. But HDMI is really kind of proprietary or whatever. You have to pay to use it. If you can't put the HDMI logo on your stuff. I think that's why the Parallax thing says digital video output and not HDMI. But it'd be nice to play around if we could figure that out, how to do that. For hobbyists, you can probably get away with not paying anything to do it. So, you know, like I said, there's passive adapters that can switch between all these different kinds of digital adapters. Here's like an example of one. Um, yeah, there's some caveats to it. You gotta be a little careful. They might not do that dual link. Some of them won't do audio, and sometimes they're just one-way adapters. But and this is the Parallax one for the eval board. This makes it really easy to use. This little tiny board, you get HDMI output. Some TVs seem to need the 5 volts. So you see I added in my own little jumper wire there to connect this 5 volt to the 5 volt on the header. And some monitors don't seem to need it, but some TVs seem like they do, as far as I could tell. And we're using, there's some other pins here that are kind of interesting. There's this the DDC display data channel using the SCL and SDA pins. You know, the VGA has that too, and it's a way to talk to the monitor and get information about it. We don't really, I haven't seen too many people use that, but it's kind of interesting. It's also used for encryption. And that if you want to do that, you probably have to use that HPD pin, hot plug detect. And it's also an interesting thing I was looking at, it's possible to get audio from the TV using that pin and also the RSVP reserve pin. Another interesting is that CEC pin. It looks like you can actually get information from your TV remote control using that pin with a one-wire bus. So that might be interesting to check out. So probably what might be the most, or what, well, at least a very interesting thing to do with the HDMI is to talk to these new LCD panels. A lot of the new LCD panels actually have HDMI connectors on them, and that's really convenient. And they go up to like 800 by 400 resolution, which it's kind of a nice place to be with these displays. Are in the range from 4.3 inch to 7 inch. And yeah, Ken just showed one that he's gonna sell. That's nice. And they typically use this Texas Instrument chip TFP401 to decode the HDMI. And later on, I'll talk about its companion, the TFP410, which is a display port encoder. But these don't have sound, so this is not the HDMI way, it's just the regular digital video way. And some of them have USB touch panels. So that's kind of a nice, convenient. We can hook up USB and HDMI to talk to these panels. It's kind of nice. If you want to add your own HDMI adapter to a board, it's really easy. Like you can see an example of what I did in Eagle, and you just run straight wires. I just ran straight wires straight from the prop to the connector, and it works. And I recently added in that 5 volts, so I don't have to worry about that. But VGA is also kind of competitive here, because with that you can go to higher resolution and only needs 5 pins, and the quality wise it seems kind of similar to me usually. So you have to think about which way you want to go. The code wise, this is an example of screenshots from HDMI at 16 bits per pixel versus VGA at 16 bits per pixel. And if you look closer, it's really similar. Some of the setups a little different, some of the the constants down here are a little different, but overall it's almost identical. So that's kind of interesting feature. So VGA, we'll talk about that now, that's a whole lot better now than it was with P1. You might recognize their typical P1 setup with your 6-bit color. You need these external resistors. Where now with a P2, you just hook directly to the pins. The pins all have a DAC in them that can output 256 colors. And we got that lookup table, so we can do, the hub RAM is big enough to store full frame of VGA at 8 bits per pixel. So this is, we're much better off with P2 now. This is getting into the guts of the streamer modes we use for this. There's a little difference between VGA and HDMI. Yeah, I don't want to talk too much about that, but just that's just the different things you need to set up your different video modes. That's kind of down in the weeds. I'm just going to skip that. So now, what if you do want digital video at a higher resolution? The one thing you might think about is using the TFP410 to turn the VGA type signal into into digital Visio. So for that, you might want to use the 24-bit. You need 24 pins from the P2 to go over to this chip, and then it'll output HDMI. So that's using a lot of pins, but you get the high resolution this way. And this is an example. I've used this chip before with the P1 using this SSD 1963, and so that works. And it's fairly straightforward. You got to talk to the chip either using pull-up, pull-down resistors or I2C interface to tell it what resolution you're working in. But so I'm pretty confident that would work. And that'd be a way. It doesn't have sound, but you could get high resolution output that way. What I really like to use is this chip here, this ADV7513 that I found on DigiKey, but that you can't buy it from them. I was going to buy it from Analog, but there's this note here saying you have to be an HDMI adopter to buy this chip. And I looked into that, and that's several $1,000s to do that. So yeah, so that's probably not going to happen. You can buy them from eBay from China, but yeah, I think I might not go that way. I'll tell you one other, probably a better way to do this is just take your VGA output from the P2 and use one of these adapters you can buy to just go straight to HDMI. And what's nice about this is you also get the audio in there. They're pretty cheap. And I have one like this bottom one that I've tested, and it works fine at 1080p. So I think that might be the way to go. And if I was going to put this in something like a set-top box, I'm going to just buy this top version, take it apart and put the guts of it inside my box. That's just what I'm thinking. So when you want to do higher resolution video, this might be nice for showing static images or a slideshow, things like that. You can use the HyperRAM and HyperFlash as a display buffer to let you do that, because some like this 1080p image, that's way bigger than hub RAM. But the HyperRAM kind of makes it easy to get more memory, fast, high-speed memory to the P2. And the driver allows you to read in 8-bit data at clock over 2, which means up to like 150 megabits per second, maybe even faster. I've seen some people talking about a clock over 1 drive interface, and I don't know if that'll work very well or not, but that'd be really nice too. So the difference between the two, HyperFlash is kind of like is flash memory. It's kind of harder to write to, but it's easier to read from. And also HyperFlash is static. It keeps its data when the power's off. Parallax sells this module here. It was very convenient to add to your setup with both a HyperRAM and a HyperFlash. I posted some code for this in the forum. Loading up this image takes about a second. I'll talk a minute later. That's from microSD. I'll talk about eMMC, which is a way to do it faster. With these chips, you can store about 7 of these images in HyperRAM, 14 in HyperFlash. And a guy in the forum at Roglo is working on a driver. So that might be interesting when that comes out. So there's also going to be real nice working with these regular display modules with the P2. So there's kind of generally 2 different kinds of these. There's these little ones that have integrated RAM. They have the screen buffer internally, and you talk to them over a 8-bit or 16-bit interface or SPI. Usually you'd want to use 8 bits with the P1 to save pins, but now it'd be kind of nice to be using the 16-bit interface. And the larger ones usually don't have RAM, and you talk to them over 24-bit interface, and they have resistive or capacitive touchscreens sometimes. And these ones kind of work like similar to a VGA monitor. They have your sync signals and stuff like that, but instead of RGB, it has this 24 bits of color. With the P1, I usually didn't use all 24 bits because I didn't have enough pins. But now with the P2, maybe you can. And so writing GUI code for these should be like falling off a log easy. So I haven't done it yet, maybe because it's not really a challenge for me, but I think it's going to be really easy to do and fun too. So the one kind of nice thing we're able to show is that you can actually instead of we could do 24 pins, but maybe you don't want to. The P2 is fast enough. You can actually you can get 24-bit colors with only 8 pins using some external chips. So here's my little test setup here. It's got 2 octal latches in there. And thanks for JMG on the forum for helping me out with this. But we're able to actually, this is kind of like a little FIFO here. We're using 8 pins. We latch them into one chip, and then latch the next set of 8 bits into the second chip. So that gives us 24 bits going out to the screen. So it's kind of a neat trick to save pins, and it runs at the full speed. So that's kind of nice. And the P2, so this is kind of a good fit to P2 without a whole lot of external stuff, because the memory in P2 is big enough to hold to double buffer that. So that's not nice. And here's the code that does it. It's very simple. Just this little thing to latch the data out, and then toggle the clock pin on the screen. So it's very straightforward there. By the way, this is a spin edit here, which is not much of a challenger for Prop Tool when it comes out, but it's working for me in the interim until Prop Tool comes out. So anyway, so there's some newer kinds of interfaces coming out for larger displays, HDMI, LVDS, and Eve. So LVDS that's one I don't really know too much about. It's kind of similar, but not the same as what HDMI uses. I don't know how easy that's going to be with P2. I saw somebody in the forum looking at it, but I don't know too much about that. HDMI we kind of talked about, and the WVGA resolution is kind of a good fit. But what I'm spending a little bit of time talking about now is the Eve 2 based displays. And this one, so instead of having that, some of them have the HDMI decoder chip on there, and some of them have this Eve 2 chip. The Eve 2 is kind of nice because it's a GPU actually, meant for microcontrollers, and it has a SPI or QPI interface, and it has a megabyte of onboard RAM. And there's new versions, Eve 3 you can actually get now, and Eve 4 is coming out soon. But there's a lot of Eve 2 stuff out there from different suppliers. So I've worked with I have spin 1 code that I've posted for Eve 2, and I've just recently ported that over to the P2 and connected it up to the P2, and it actually seems to work. And I'm now looking at doing to this, because we got so many pins now, I'm going to switch this over to the SQI mode, so that's going to make it even better. And I'd just like to mention fast spin here, because that makes it really easy to take my old spin 1 code and get it working on the P2. And then now that it's working, I can make it into a version that works with both fast spin and the Prop Tool or Peanut. So thanks, Eric Smith. So Eve 2 displays make doing your GUI really easy. They make it easy to do things like buttons and knobs, sliders, rotary dials, and it also has manages the touchscreen for you and tells you what buttons were pushed, the position of sliders and rotary knobs. And so that offloads a lot of work. There's also audio processor, but it's mono. I don't know why they didn't make it stereo with the new versions, but still mono. And yeah, I think we can do audio probably better with the P2. And I know people are working on audio drivers with the P2. So I think I might not use its audio, but use the P2 audio instead. And the way it works is you make a display list. So once you have the driver, what you do is you create a display list, and it's very similar to OpenGL, where you start a list, you add some stuff, finish the list, and then it magically appears on the screen. And here's getting down to the weeds a little bit. There's just a little example about how you can interface with the driver. And my driver here is very similar to the C driver, because they're both related to the core instructions of the Eve 2 chip. But in this first part here, what this code does is it shows an image on the screen, and then it moves that image around with your finger. And so the first part of it, what it does is it loads an embedded image from the hub RAM, a PNG file, image file, copies it over to the Eve2, uh, um, unpacks it and stores it into, decodes it and puts it into its memory. So you do this using the display list commands, just like you're doing regular video. But you start your display list, clear the screen. This one is what loads the image, that copies that image over, and then you end the display list. And once you end the display list, it gets to work and does what you asked it to do. And then we go into the loop where it looks for your, it shows the image on the screen. As you can see, it starts the list, clears the screen, puts some text on the screen. You gotta do some magic incarnations to get your bitmap. Because the thing is, it doesn't know the particulars about your bitmap in its memory. So you have to tell it. And then you do this vertex command to tell it where to do the bitmap, and it does it. And then you end the display list, and then it shows up on the screen. And then what this loop is doing is it's waiting till somebody touches the screen, and it does that for you. And once it checks, I'm polling here to see if it's been touched. Once it's touched, I update X and Y and go through the loop again to show it in the new position. So that's kind of a fairly, not too complicated way to do something that's kind of complex. So like I said, the Eve2 includes that image decoder. It works with JPEG and PNG files. You can also do MPEG movies with audio, which is that's kind of nice too. And I really want to get that going. I tried with P1, I couldn't make it work, but there's some new tools that I just found that I think I can get this going. So one of these new tools is called Screen Designer for Eve, where you can kind of lay out the stuff you want on your screen and see what it's going to look like. So that's kind of convenient. The code itself is kind of strange and it doesn't seem slow to me. And it took me a while to figure out. I had to watch videos to figure out how to actually make it work. The trick I figured out is you have to click on this fixed position window before you add stuff. I don't know why that is, but you do. So it's kind of a trick there to make that work. But it's kind of nice, and it'll run a simulator that'll show, you can interact with it like it was a real touchscreen on your computer. So that's kind of interesting. It's kind of targeted for their own series of microcontrollers, so that's kind of a downside, but it's still kind of useful to seeing how things will look and try and test out the different internal fonts. And finally, there's also this asset manager tool that's kind of nice, and this will convert video into a format it understands. So I think this is what I might use to let me get video going. So I'm kind of interested in looking at that. And it does something with fonts, and looks like it'll manage the flash. So it's kind of a nice tool there, looks like. So I'm kind of excited about some new versions of Eve that are coming out, Eve3 and Eve4. So what Eve3 adds SQI flash chip. And what's nice about that is it can actually show video images directly from the flash in real time without having to copy it into the 1 megabyte hub RAM. So it kind of expands on that 1 megabyte RAM it has internally and makes it even bigger. And they've also upped the SQI speed. I think the original chip was supposed to be 30 megahertz, but it's not. They had to derate it, I think. So it's 25 megahertz on Eve2, but Eve3, it's back up to 30 megahertz. Eve4 is going to let HD work. So we're going to get up to 1280 by 800, which is kind of nice because I'm looking at 720p with this thing would be kind of pretty sweet. And also the SQI interface speeds bumped up to 40 megahertz with this thing. I think they were actually going to announce this at this conference in Germany this year, but that conference got canceled. But so there's not too much information about it out there right now, but I was able to find some of these images here that show you kind of the features. So what I kind of like to try out, what I'm about to test out, I just ordered these boards. I'm gonna see if I can turn that 24-bit color, instead of going to LCE screen, see if I can send that out to a VGA connector. Because I kind of like to see the 720p graphics from this thing, see what that looks like. And I'm going to do that using this ADV 7125 triple DAC chip, which turns that 24-bit color into 3 colors. Yeah, so maybe I could do that with the P2 also. You send that back into the P2 and then output VGA, but I'm gonna try this, see what it looks like. But now I'm gonna talk about what you can do with just the native P2, not using external stuff. This is an example I spent a lot of time on. It's kind of just a, a, a GUI, a 2-bit GUI with graphics. It has a mouse cursor. And here's an example using it with forming a mixed signal scope where it has 2 channels of analog data and several channels of digital data. And it has your sliders and knobs and stuff. And this kind of worked out really well. I picked 1080p because modern monitors all take that. Yeah, so we don't have enough onboard memory to do super fancy graphics at 1080p, but this 2-bit per pixel seems a good fit. I'm using the 16 by 16 tiles just like P1, and I'm actually using the chip's old graphics.spin adapted for P2. Maybe there's probably a way to do it better, but that's what I did. It works pretty well. And it using the USB mouse. I have to thank Gary J there in the forum for making that work. And this thing, although it's similar to the P1 style graphics, is actually a lot better in that each tile can be one of 256 colors for both foreground and background. So that you can do, that's why I can get all these different kind of colors in here. And this particular example is also kind of useful for playing around with the smart pins. It has a smart pin configurator, and all these little SP buttons bring up smart pin settings for each of these pins. So it's helped me learn. I learned a lot about the smart pins using this. So let me just tell you a little bit what's going on the inside there. I'm using a lot of cogs. That previous example actually uses all the cogs and most of the RAM, but the GUI itself uses 4 or 5 cogs. Actually 5 or 6 cogs. So here's the kind of these can be rearranged, but this is just how I had it. Right now there's 3 cogs free if you don't need fast graphics. One of the cogs has slow graphics built into it. If you need faster graphics like that other example did, you're going to need to use this another cog. That only uses 2 cogs. And for that other example, the scope example, I used 1 cog for direct digital synthesis, so that needed a cog, and another cog was used for capturing the data. So that's why I used up all the cogs. And one other kind of interesting thing here, I show these 2 cogs being linked, and that's because I'm using lookup table sharing, which is a kind of a cool feature in P2, where these 2 cogs have their lookup tables joined. And what this one is doing the VGA output, and it's cycling through a set of 8 colors. And then the way I get more than that is this guy is updating the colors in this lookup table. That's kind of a trick going on there to make that work. And it also has a cursor that the scanline builder adds in. And so it was kind of a trick to get that going, but it all seems to work pretty well. So now I'm gonna get to multimedia, which means adding in some audio and mass storage. The audio is much better on P2 now, and for the mass storage, USD, several people have got that going now. I kind of like FSRW, and thanks to Jesus for making that work. It gets pretty decent read speed. Still a lot to do there. The FSRW is kind of a minimalist implementation, and now with P2, there's so much room. You could probably, there's probably room to enhance that. And I think some people, I think Ken even showed something that might be new there. One thing that I recently got going was eMMC, which is kind of a 8-bit version of microSD, which is very nice. And I got read speed more than 10 times faster. And that's very convenient for doing multimedia. Camera, I really want to get a camera going. I had code working some time ago with the FPGA version. I'm going to get going again. I think there's still a lot of work to do in that area. I don't think it's seen a whole lot of microphone code. Yeah, I think Chip has a demo doing it. That's another area that needs kind of work, I think. So here's just something about showing how much better the audio is. And you remember with P1, it was kind of actually digital output. You had to filter before you send it to the audio chip. And now, because the the pins have the DACs in there, you can just go straight out to the to your audio. And the same for and the mic has the ADC, so that makes that easier. Okay, so the eMMC, I mentioned that earlier. If you don't know what that is, a lot of your stuff probably actually has it. Like here's a guy that took his Alexa apart, and you see down in here, there's the main processor, there's a Hyper RAM chip, and then there's eMMC chip next to it, and then this Wi-Fi chip. So that's what makes the Alexa work. And it's kind of a nice setup here. If this is a P2, that'd be kind of convenient. So the eMMC, it's kind of based on the old MMC standard, like there was before SD cards. And what's nice about that is it's kind of an open standard. You don't need any special licenses. USD has, micro SD has a 4-bit bus option, but you kind of, legally using that, it's kind of murky. I don't really know. A lot of people don't want to use it. So, but that's nice is the eMMC gets around all that. And the interface is very similar to micro SD. It didn't take me too long to get this going. And at 28 megabits per second, you can now do 480p video, even at 60 hertz if you wanted to. The only thing there is now you start to worry about running out of space. Yeah, even though the chip itself is file, without compression, this uncompressed video takes up a lot of space. And you actually run into this limit of the file size. It's actually formatted as FAT32, which has a 4 gigabyte limit on your size of files. So you can do it, but you probably, if you want to do this, you probably have to split this file into several smaller files. And it's also nice for loading up images. You know, it took almost a second to load up a 1080p image with the micro SD, but now with this thing, you can get it in around 100 milliseconds, which is good for, you do slideshows directly from the chip. Well, you load it into HyperRAM, I mean. And this thing actually has high-speed modes, HS200, HS400, which if we could get that going, that'd be amazing. But I think this appears like it only works at 1.8 volt IO voltage, and I don't think it's going to work with P2. I'd love to be wrong about that, but without some kind of level shifter, I'm not sure that's going to work. So the thing about, if you want to add this to your own board, this thing looked pretty intimidating to me at first because there's like so many pins, but and it's a VGA package. But it's actually, if you look close, it only uses a very small number of these pins. And you can actually lay this out on just the top layer, as it's shown over here. And I was about to do this, to lay this guy out on my own board, and I said, you know, I thought I'd take another look at what I can just get off the shelf. And I found this thing, which is the eMMC chip on a nice, you know, kind of easy looking header there. And I can buy these connectors off Mouser. Yeah, and it's off Amazon, so it's kind of twice the price of the chip itself. It's not horrible. But I did make a mistake. I thought this is 0.1 inch header, but it's actually half that. So it's kind of a tiny header. But I was able to find this connector on Mouser, and also SparkFun sells a little SOIC adapter that the header fits to. Got that onto the breadboard and hooked it up to the P2. So it wasn't too hard. It'd be nice if there was, maybe Parallax could make us something. It'd be nice. But now I'll be able to play 480p video at 16 bits per pixel. And this is an example of the frame. You know, just like the Eve, they use these Blender movies because it's open source and you can show without any copyright concerns here. But anyway, so this is, it's actually pretty decent quality, even at 480p. I guess that you might call that DVD quality, I think. And yeah, and the one trick that makes that work is because it's widescreen, the top and the bottom are blank, and that's how I can fit the image into the hub RAM. And I made a little Windows tool to stack the video and audio into interleave packets to make this work. And that's it. What do I do? 40, oh, we're out of time. Okay, good. Thanks everybody. Thanks to Ken, Chip, and Parallax, and thanks you all for the forum members. I highly recommend the propeller.parallax.com to get information about this. And I'll take any questions.
Questions, unmute yourself, or you can type them. This is a great presentation, Ray. You did a ton of preparation.
Thank you.
While people muster up the courage to unmute themselves, how about the reverse question from Matteo Bori? Can you connect a USB webcam, get frames in, and read them from a composite video source?
Let's see, that's something I don't know much about, but I think when I looked at it, the USB cameras, they usually wanted a higher speed than what our USB interface is working on. I think we're working at full speed, and I think the USB webcams usually want a faster speed than that. I could be wrong. I don't know.
And Chip answered, he said if the camera could signal using the 12 megabits per second full speed USB to the smart pin support, then you could get data, but only at a low frame rate. You're welcome, Mateo. And so, Ray, I asked you the question, and you said it would take maybe days to collect up all the code, but some of the code for what you've shared, it's scattered throughout the forums at the moment, right?
Yeah.
And that's okay. We want to collect it up and make it available for people, or pieces of it. So as it becomes visible to people, if I could get some links to those examples, I would make them apparent for everybody.
Yeah. So my code is usually not, Johnny Mac does a good job of getting code in a nice formatted, cleaned up, and my code is a little messy sometimes, but yeah, I'm happy to post stuff together.
Yeah, totally understand. Okay, so questions for Ray.
Ray, this is Jim Schaefer. Are you planning in any way to support the Raspberry Pi family of cameras?
Well, I did explore hooking up the Raspberry Pi to the Propeller 2, and so that kind of works out. I'm trying to remember how I did that. I think there was a SPI interface where the Raspberry Pi was the master, but I kind of made, even though the P2 was a slave, I wrote code for the Raspberry Pi that kind of took commands from the Propeller 2. So yeah, we can, either way you want to do it, you can have the P2 be in charge and tell the Pi what to do, or you can have the Pi in charge and tell the P2 what to do over that SPI interface. And you could, of course, tell it to capture images from the camera and do whatever you want to do with them. So yeah, I'm pretty sure that can work.
I was thinking more of direct support of the camera itself.
Yeah, I haven't tried that out, but I think, you could, you can talk. I think you can make things work. I haven't really looked into it too much.
Okay.
Yeah, that'd be another way to get a camera going. That's probably an easier way than hooking it up yourself to the P2. But yeah, that's an option, definitely.
Yeah, so the P2 can do composite video. I guess decoding the color or so, like to do that in real time is not quite too easy.
Yeah, I've seen people try that. So it's kind of that'd be really nice to do, actually, because there's a lot of the super cheap cameras have a composite output, and if you could capture that, that'd be nice. There are chips that'll decode it for you, and send color information over to the P2 chip digitally. But if you could get it from the analog signal, that'd be kind of a neat trick too.
Yeah, yeah, it's kind of a good test for ADC performance as well. So,
Yeah, I haven't seen anything about that lately. There was people working on it before, but that would be nice if if that could work.
mm, you know, that was probably me working on that.
Yeah, okay. Actually, even just black and white could be good enough for some things, you know. So
Yeah, maybe I will try to clean that up a bit and get more of it released.
yeah, that'd be good.
Ray, how about your suggestions on incorporating HyperRAM into future educational boards that we might make? Sounds like it's a strong suggestion.
Yeah, well, I'm kind of I lean two ways. And sometimes I like the minimalist approach where it's just the P2 and see what we can do with just that, so you're not reliant on other things. And then sometimes I want to push the envelope, and then I want, you know, everything together. So if we could get a board with the P2, a Hyper RAM, and that eMMC chip on there, that'd be pretty sweet. Maybe it's that Wi-Fi. I kind of like that Alexa setup there, the Wi-Fi chip, Hyper RAM, and eMMC.
It's good. Okay, more questions for Ray. And Ray, you could stop your screen share too.
Oh, let me see. Aha. Oh, now I can see everybody. All right.
So a question came in about the minimal display requirements for video for our drivers. Maybe that's for you, Chip. Unmute yourself.
Actually, that was for Ray. I'm
Oh, good.
sorry.
Okay. Thanks, Dennis.
I have an inexpensive display. As you can see, it's displaying some of the graphics from probably from E.R. Smith's sample code. When I tried a couple of Ray's drivers, I get a half a screen. So I was just kind of odd. Maybe this display is just not appropriate for getting a real good display at maybe 1080 or 720. So is there a minimum that I need in a display?
Oh, I don't know why that. I don't know what. I don't recognize that. Is that a computer monitor?
Yeah, basically it's a cheapie bought off of Amazon, a VGA and HDMI monitor display. I can go on the forum and send you the spec on it or what I've got on it, and maybe you can see what's missing or what's not quite there.
Yeah, it's kind of a smaller screen, but sometimes they take 1080p. I don't know. I have a little one, 14-inch that takes that does it. That can work with 1080p.
Mm-hmm. Yeah, I've tried
That
different
one,
modes too. I've tried some of your, like 640 by 480, and it still gives me some oddball, out of sync type displays. So I was just kind of curious if there was some kind of minimal that we could all say, oh, okay, at least I've got this, and that'll work.
yeah, the 480p should definitely work on that. So if it doesn't, something's wrong.
Okay.
Actually, I'd say, I don't know what's going on there. There is something I did notice with I think all of our VGA drivers, the V-Sync is off by one line. Most monitors don't seem to mind, but there's a thing about where on the VGA drivers, when it does the sync, it does it by doing directly to the pins, whereas the streamer is kind of behind. So that makes the VGA V-Sync a little off. I don't think that may be the problem. It doesn't seem like it though. That sounds like something else going on.
Okay. I'll catch up on the forums. I'll send you my details.
Okay, glad to help.
Sure.
Okay, the other day, Ken sent me a little HDMI panel that he got a hold of that I think will be selling, and it's 800 by 600, and I found that you can signal it from 250 to 320 megahertz. But I made the little spiral thing work in 800 by 480. So just,
What's the resolution? Is it 800 by 480?
yeah, 800 by 480.
Okay. Yep. Yeah, that should work pretty. That should be a nice place to be there. Yep.
We should have those in stock in about a week.
Yeah. Sometimes a lot of them have the touch panel. Sometimes you don't need the touch panel. So if you don't need it, then that should be really nice.
Yeah, for those who are interested in that display, here's the back of it. Sorry, and it's a 5-volt.
Yeah,
Power
it takes running this. I don't know if you can see that, but it's taking about half an amp at 5 volts. 2.5.
Yeah, that sounds about right. Yeah, the big screens they use a lot of current for the backlighting. So,
Yeah.
Yeah, so that's the only challenge is you might need more than one USB power, because USB power is only around 500 milliamps, which is kind of what those screens want too. So yeah, you have to just be a little bit careful with the power, that's all.
Oh, I see, yeah. I have this plugged into a power supply here. I never thought about running it off USB.
So what is the state of drivers at with video then at this point? Ray said it was really trivial. I haven't actually used them yet, but maybe one of you can comment.
Well, Ray, I think, has written quite a few more than I have. When I start making objects, I will come up with a bunch of standard things, but I think at this point in time, Ray's written quite a few.
One thing that Ray showed that I think that'll really help us is in laying out a display, like a control panel or some feedback. He had this graphical software example. And that'll really help before you try to put in code, at least for me.
Yeah, I think a screen designer for that kind of panel, I think it probably exists already a bit, but I could write one pretty easily, I'm sure. And yeah, we need to get fonts. We need to get some fonts going.
And I'm curious too of anybody participating, if you're doing a production type project, if you will be using a display in it. We're always interested in that, what people are doing and what kind of peripherals they're connecting. So do let us know.
Right. Well, I was hoping I was going to keep this under an hour. Looks like we did that.
Yep, perfect timing. Ray, want to thank you so much. This was certainly very well prepared, and you conveyed a ton of information. And this will live on our YouTube site under the playlist Propeller 2 Live Forum. So it'll be our second video. And we thank you tremendously for taking all the time. I know what it takes to put all these slides together. You did 40 hours of work, which you've just shared to all of us.
Yeah, well, I wish I would have spent more time on it, but I did what I could. Happy to help.
Yeah, and that's the thing. So for future presenters, we don't, this is a high bar Ray set here, but really any kind of sharing you can do is great. If you have limited time, that's okay. We'd rather see what you're doing than with whatever time you have.
Thank you, Ray. Enjoyed that. It's really informative, and I like to see what we can do with the displays. You know, I do like the minimal approach, but I also like to see there's certain products you need all that graphics and so on, and just to see you doing that, Ray, and doing all that work on the presentation as well. That's been really helpful. I really appreciate it. Even though I'm a bit tired tonight, I'm staying up to take it all in. Thanks.
Yeah, what time is it there in Australia? It must be like middle of the night or something.
Yeah, look, you know, it's still fairly early. It's only 2 o'clock in the morning, but I had a 4 o'clock morning yesterday and all that. So, you know, occasionally I get some sleep. That's good.
Yeah, it's kind of amazes me how there's so many forum members from Australia. It's and yeah, it used to be a lot from Germany, and now it seems like everybody's in Australia now.
And our next presentation has another Aussie, but he's living in the UK.
Mm.
And what's interesting too is they're all within like 50 or 100 miles of one another. Great. Okay. Then we'll conclude and get our day going. Thank you, everybody, for joining, and see you on the forums.
All right, bye.
Bye now.
Bye. Thank you, Ken. Thank you, everyone.